1, limit from the left, limit from the right, and finally the double-sided limit. These are the 4 things you need to find. What is the value at 1? What is the limit from the left? What is the limit from the right? And what is the double-sided limit? So let me go ahead and copy this down. So level 4, number 1, we have of course a piecewise function here, as you all can see. Alright, and we need to find f of 1. We need to find the limit as x approaches 1 from the negative side, from the left side. See, I'm already making a mistake. We should say left, not negative. Then we need to say the limit of f of x as x approaches 1 from the right side, and then the double-sided limit. Okay. So, the way we're going to do this is by constructing a table. When we solved these problems on the graph, we simply looked and said, what is the graph getting close to on either the left side or the right side? Now, unfortunately, we don't have the graph, but we can use a table on the calculator to solve this problem quite straightforwardly. So how are we going to do this? Well, if you think about a number line, just briefly, here's -1, here's 0, here's +1. We want to find the limit both from the left and from the right. Well, if we're finding the limit from the left side, it seems to me that some possible values for x would be like 0.9, 0.99, 0.999, 0.99999. Try to get closer from this side. So let's write those values down. 0.9, 0.99, 0.999. So in other words, we just picked 3 values that approach 1 from the left side. 3 is enough. We now need to pick 3 values that approach 1 from the right side. 1.01, 1.001, 1.0001. We're simply picking 3 values on the left and 3 values on the right that get closer and closer to 1. Are there any questions on the logic of picking the values and how I got them? If so, please ask. Okay. Now we're going to use the calculator to determine what are the y values that go along with these x values. So I'll just walk through this step by step on both calculators. Does anybody have an 8384 that you see me do it on? Is this totally fine? Don't hit that. Okay. So at 8384, go to y equals, and we plug in this graph. Now the question is, and inspired people can be doing this also at the same time, how do I know which piece to plug in, right? That's the question here. There are 2 pieces. I got to figure out which piece to plug in. If you think about it, the piecewise function says anytime you want an x value that doesn't equal 1, use the top. And anytime you want an x value that does equal 1, use the bottom. All of the x values we care about, all of these x values we care about, do not equal 1. We therefore must use this top piece right here. Any questions on that logic? Go ahead and plot this top piece. Please correctly use parentheses. That means put parentheses on the top, divided by parentheses on the bottom. And then click run. And we can do this on both calculators. It doesn't matter what you see on your calculator. I can just make the default window though, so zoom fit, or zoom standard rather. And here we go. Alright, so now both calculators are displaying the picture. Okay, so before we go on to this, is there anybody who does not have the picture? Okay, here. Can we type it in? Okay, Shelly. Is it typed in with the correct table? Can you check? Is the parentheses correct? Okay. Are the parentheses off? Our window was different. Picture was the same. I'm sure it's basically. Okay, so because we're just having some issue with this, let's look at the Inspire. On the Inspire, folks, here's what you need to do. Click Control and then T. Inspire. Control, then T. The letter T. Like T for table. And your table should pop up on the Inspire. Control T, you should have a table. Folks, we're going to need people to be very, very locked in here. Guys. We now want to get to a point, because notice, the values that are given right now for x are like 0, 1, 2, 3, 4, 5. We do not want 0, 1, 2, 3, 4, 5. We want 0.9, 0.99, blah, blah, blah. So we need to be able to tell the calculator, hey, don't use the values you default to, don't use these standard ones, let us plug them in. Here's how we do that. The table is up. Click Menu. Okay, you should have a drop down. Go to number 2. Okay, and then one of these should say Edit Table Settings, number 5 on mine. Could be different on yours. And we should get a box pop up like this. Yeah.
Yeah, you gotta go to table.
Is your table on? You gotta be clicked. Okay, you gotta be clicked in the table. So make sure you're like the cursor has clicked in the table. And then click Menu, Table.
You gotta go to Inspire.
Yeah. That's what I said, right?
No, you said 2, but on ours it's 5.
Oh, it's 5. Okay.
Yeah, it's 5.
Edit Table Settings. Okay, now this box pops up. You want to go independent. That's the X variable, and change it to ask. Change the independent to ask, and then click OK, please. So independent is ask. Dependent stays as auto. Independent goes to ask. Click Enter. The table should go blank. Inspire, folks.
Yeah.
Now you tell the calculator which X values to plug in. So, for example, plug in 0.9. There's the Y value. This Y value is written right here. Okay, then 0.99. That Y value is written there. Fill in the whole table. Questions on Inspire, folks? And I'll get to yours. Okay, fill in the table, please. A3, so Shanli, are you here now? Picture? So go to second window. And just put this on ask or independent. You guys, Shanli? Yeah. And then second graph. Is your table blank? So now just like plug in the X values you want. Let's fill in the table. Brianna, go ahead, please. 3, please. So let's go ahead and fill in the table. 0.526, 0.503. Folks, we don't need too much discussion on this piece.
That's the 3 then?
Mm-hmm. And here we are. Again, if you're off by like one random decimal out here, or like rounding, it's okay. I'll change that piece later. So now you just need to look at this and use some like logic here. The limit as x goes to 1 from the left. This is the left. So the limit, what is happening? The y value is getting closer to 0.5. The limit as x goes to 1 from the right, that's this side. Again, we're getting closer and closer to 0.5. And what is the double-sided limit? Well, the double-sided limit, we said, if the limit from the left equals the limit from the right, then the double-sided limit is exactly what that was. There we are. And now the last piece, verify that you agree with my f of 1. Before I do another problem, I want to stop here and see if there are questions. How did I get the f of 1 equals 2? Good question. Look at our piecewise function. This says any. Questions? Okay, let's continue on, please. The next one I want to do is on page 6. And it is problem number 5. Right here. And many of you are capable of doing this on your own at this point after you just seen me do one. If so, please go ahead. We need to find the limit, number 5 here. We want the limit as x approaches 2 on both sides. And again, anything you need to verify, you can look up here. I'll do this without saying much, just to give people the time and space who feel a little bit comfortable doing this already. If you have questions, let me know. Can troubleshoot. My work is up here for those who are ready to check. These or this big one? Because of the limit from this side is 0.2, getting closer to 0.2. This is the left limit from this side.